some vocabulary terms that you need when solving complex fractions. The first and most important is complex fraction. A complex fraction is when you have a fraction within a fraction. For example, 1 plus 7/4 over 3. The next term is LCD, or the lowest common denominator. The lowest common denominator is the smallest number that both of the separate denominators are factors of. One way to find it is to multiply the two denominators by each other. For example, 4 times x equals 4x, so that's the lowest common denominator. The next term is simplifying. Simplifying is when you factor out a common term and you divide it out so that you can get the lowest possible fraction. For example, 4/8 simplifies to 1/2. Next, we have combine like terms. In this case, you want to combine any terms that are alike. For this one, we combined 3b plus 4b into 7b because they were the same kind of term. You couldn't combine 2 because it didn't have a b. Next, we have factor. Factor is when you make the most important operation, multiplication. You can do so by pulling out a common factor, in this case 2, and making it multiplication. So 2 times the quantity of b plus 2c. The final one is expression. Expression is a math term that means it's not an equation, so it can't have an equal sign. Like this has 3x plus 4 equals 6. That's an equation, it's not an expression. 3x plus 4 is an example of an expression.
Method number 1 for simplifying complex fractions is used when you combine the numerator and the denominator into one fraction, and then you rewrite the complex fraction as a horizontal division problem and evaluate to find your simplified answer.
Number 2 is when you find the LCD, the lowest common denominator, of all the denominators and multiply the numerator and the denominator by the LCD and simplify.
So, for method number 1, the first thing you have to do is focus in on the numerator part of the fraction. And to start, you find the LCD, which is 3x squared y squared. And now that you have your LCD, you have to take these fractions and make them into one fraction. So now, you do the same thing that you just did with the numerator part of the fraction to the denominator. So to start, you do the same thing and you find the LCD of these fractions, which is x squared y squared. And then you take the LCD and you find the new numerator of that fraction. And from there, you do the same thing that you did right here, and you take the numerator, the sign, and the other numerator, and put it all over the LCD. So, now what you do is you take your fraction from the numerator and your fraction from the denominator and set it up to be one expression. So the numerator divided by the denominator. And to solve that, you solve it as a normal fraction division problem. And you take the first fraction and multiply it by the reciprocal of the other fraction. So you're going to take your denominator fraction and flip it and multiply that by your first one. And then to multiply that, you're going to factor out each numerator and each denominator so that you can cancel out. This is how I factored it. Only one thing in this problem was factorable, which was the y squared minus 25x squared, and that is the difference of perfect squares. So I factored it as y minus 5x times y plus 5x. And then you leave everything else the same, and you're able to cancel. So you cancel by crossing out the things that match on the numerator and the denominator. So that would be this, 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 and that. And then you finally have your answer, which would be y minus 5x over 3.
Okay, so for method 2, the first thing you have to do is find the LCD for both the numerator and the denominator combined. In this case, it's 3x squared y squared. Then you multiply the whole problem by 3x squared y squared over 3x squared y squared. It has to equal 1. Okay, so I multiplied the original equation by the LCD over itself. By doing so, I came up with this equation, which I then crossed out factors. After crossing out everything, I got y squared minus 25 over 3y plus 15x. Now I just have to factor it to get the final answer. So in the numerator, we had a difference of perfect squares, so we were able to factor it to y minus 5x times the quantity of y plus 5x. In the denominator, we were able to pull out a 3 to get 3 times the quantity of y plus 5x. We can then cancel out the two y plus 5x's to get the final answer of y minus 5x over 3, which, as you can see, is equal to the answer we got in method 1.
For our next example, we are going to solve n plus 5 minus 12 over n plus 1 divided by n plus 9 over n plus 1 minus 5 over n. So I'm going to show you how to solve it again with method 1, which is where you take the two fractions and combine the numerator and the denominator and set it up as a horizontal fraction division problem. So the first step is to recognize that this one right here, this part of the numerator, is the only part that's not in a fraction. So what you're going to do is you're going to take n plus 5 and put it over 1 so that it matches the other fraction in the numerator. And then the first thing you're going to do is put the numerator into one fraction like we did in our other example. And you're going to find the LCD, which is n plus 1, and set it up so the fraction is one fraction over the LCD. And combine the numerators to get this one fraction. You're then going to repeat the same thing and find the LCD of the denominator until you get one fraction down here, as you did in the other examples. Then, what you're going to do is set it up as a horizontal fraction division problem. And you are going to multiply by the reciprocal of the denominator fraction, just like that. And to multiply, you are going to factor. And here we did this, and we did n minus 1, n plus 7, which FOILs out to be n squared plus 6n minus 7. Here we factored by pulling out an n and getting n times n plus 1. Here we did not factor and just kept it the same. And here we did the same thing and factored it into n minus 1, n plus 5, which FOILs out to be n squared plus 4n minus 5. From there, we canceled out the numerators and the denominators to get us to our final answer. So we crossed out the n plus 1, or n minus 1, because it is on the numerator and the denominator, the n plus 1s, and then we left what could not cancel out and got n times n plus 7 over n plus 5. And then in our next step, we just distributed the n to get our final answer of n squared plus 7n over n plus 5.
So now we're going to solve the same equation using method 2. First, we're going to find the LCD of both the numerator and the denominator. In this case, it's n times n plus 1. So we multiply the original expression by n times n plus 1 over n times n plus 1. By doing so, we get this equation: n cubed plus 6n squared plus 5n minus 12n all over n squared plus 9n minus 5n minus 5. Then you simplify and combine like terms. From there you factor it out. So you'll get n times n minus 1 times n plus 7 over n plus 5 minus n minus 1. Then you can cross out. So you can cross out n minus 1 and n minus 1. By doing so, you get n times n plus 7 over n plus 5, which you can then distribute the n to get the final answer of n squared plus 7n over n plus 5.
So for our next example, we are going to simplify y over x minus x over y divided by x plus y over xy. So the first thing we're going to do is combine the numerator into one fraction. And to do so, we're going to do the same thing as we did in the other examples by finding the LCD. In this case, it's xy. And we are going to get the numerators by which is not included in the denominator and put it into one fraction like that. And then to get our bottom part, we're just going to keep the same thing because it's already combined into one fraction. To simplify this, you take your numerator fraction and your denominator fraction and set them up as a horizontal division problem of two fractions. And to divide two fractions, you take your first fraction and multiply it by the reciprocal of your second fraction. So here we set it up as y squared minus x squared over xy times xy over x plus y. And then to simplify it even further, you factor what you can. So for here, we did the difference of two squares to get x or y minus x times x plus y, which if you FOIL it out gets you y squared minus x squared. And the rest of them, there was nothing to factor, so they stayed the same. And from there, you're able to cancel out factors that are on the numerator and the denominator. So you would cancel out both xy's and both y plus x's, which would leave you with y minus x over, you would count this as 1 because you canceled both of the factors on the bottom out, which leaves you with the answer y minus x, which is the same thing as y minus x over 1.
Okay, so for method 2, you have to multiply the original equation by the LCD over the LCD. In this case, it's x times y. After doing that, you'll get the equation y squared minus x squared over x plus y. Then you have to factor the equation. In this case, we have a difference of squares, so you get y minus x times y plus x. And then you can cancel. So you can cancel x plus y and y plus x, and that leaves you with y minus x to get your final answer of y minus x.